I welcome you all in this session. As you are aware, in previous session we were discussing how to crash a project. So we were solving this question, and in this question we have seen that the initial duration of this project is 16 days and initial total cost is 740. After that we selected critical path, and along critical path we selected that critical activity which had least slope, right, and we reduced the duration of that activity from 4 to 3 days, right, and now the total duration is 15 days. Okay. So and the total cost would be what? Here it is 1700, right. Now let us look at what to do next. Now again critical path is 1, 2, 5 and 6. What is the slope? Right, all the slopes for activity 1, 2 it is 10, 2, 5, 34, 5, 6, 25. Crash limit is now 2 here, right, because we have already reduced it by 1 day, right. Crash limit 3, crash limit 2. So let us reduce this activity by 1 more day and let us see what happens. Of course this would become 14. Cost will, again direct cost will increase by 10 rupees, that is 960, and this will come down by 50 rupees, right. So in fact here itself I know that what would be the total cost in next iteration, right. Let us solve this, right. So this 1, 2, 3, 4, 5, 6. One more point here, the earliest start time is T for this node is 3. By mistake it was written 4 here, right. Okay, so you have got 2 here now. All other durations will remain same. So 3, 3, 5, 2, 10 and 7, right. So I know that T is 15 here, right. Now it would be 14, right. So T is equal to 0, T here is 2, T here is 7, T is 3, T is 3, right. Of course TL is also known at this node. So this is 14, TL is 7, TL is 2, TL is 0, TL here is 14 minus 10, it is 4, and TL here is 14 minus 2 is 12, right. So except at these 2 nodes, at all other nodes T and TLs are same, right. So this path again remains as critical path. Total cost you can find out. Total cost is what? Total cost is now 960 plus 700, right. So this would be what? You just calculate and write down that total value, right. Right. Now what? Again reduce the duration of this activity by 1 day, right. So critical path is this, the activity with least slope is again 1, 2, right. So let me draw that network. So I hope that we have not we didn't get any other critical path. Yes, there is only one critical path so far, right. So this is 14, right. Duration is 14. Now let us look at what happens next? So let me write critical path here. Critical path is 1, 2, 5 and 6. Slope minimum is 10, then 34, then 25, and crash limit is 1, right? 1, 3 and 2, right? So I can make duration of this activity now from 2 to 1, right? So okay, so this is 1, 2, 3, 4, right? Now this duration is 1, and 1 is star. Star means you cannot further reduce its duration, right? So this is 3, 3, 5, 2 and 10. This is 7, right? So T would be 13, right? So T at this point is 0, T here is 1, T here is 6, right? T here is 3, T here is 3, right? TL is 13, TL is 3. Just see this point. Now for the first time we are getting TL and TE at this node equal, right? Okay, what about TL here? It is 11, right? 13 minus 2, this is 11, right? And TL at this point would be same 1, TL at this point 0, right? So T and TL are 0 at node 1, right? Now let us look at which path is critical path. So you have got two critical paths here now. This is your first critical path and this is your second critical path, right? Now what to do? You would like to reduce duration of this particular project, and what would be the total cost at this point? Total cost is you have got 970 plus 13 into 50, right? So this is 6. How much this? This is 650 plus 970, right? So this would be total how much? This 1620, right? So if you look at every time the cost is, total cost is reducing by 40 rupees. Why 40 rupees? Because direct cost is increasing by 10 rupees and indirect cost is decreasing by 50 rupees every time, right? So that's why the net change is of 40 rupees every time, right? Now you have got two critical paths. What to do now? So let us write critical path. You have got 1, 2, 5 and 6, right? Let me write here. So critical path is 1, 2, 5, 6 and second critical path is 1, 4 and 6. You cannot crash this activity, okay? So let us look at what is slope first of all. So there is no need, you should not write slope and crash limit for activity 1, 2, right? So this is exhausted, right? So this is slope. Whatever is slope, you cannot reduce its duration, right? For 2, 5, what is the slope? It is 34. Crash limit is 3, right? For 5, 6, what is the value of slope? 25. Crash limit is 2, right? Now for activity 1.4, what is the value of slope for activity 1.4? This is 20, right? For activity 4.6, what is the value of slope? Is 30, right? Crash limit for activity 1.4 can be found out from here, right? So this is 3 minus 1, so 2 is the crash limit for activity 1.4. For 4.6, what is crash limit? For 4.6 it is 10 minus 9, that is 1. Now what to do? Since you want to reduce duration of this project from 13 days to either 12, 10 or whatever it is, right? Because we don't know at what time duration the cost would be optimum, right? So you have to take a decision. First decision is that to reduce the duration of the project, you will have to reduce both the critical paths simultaneously, right? So what you can do, you can first option is what? You either reduce activity 2.5 or 5.7, any one of these two, and 1.4 or 4.6, right? So for this, first of all, again the least cost slope will help you in reducing activity, in selecting critical activity. So the least path here is the least slope here is 20, and for this 25, right? So select activity 5.6, this is for 1.4 and 4.6, so this is 2.5 and 5.6, not 5.7, right? So what to do here? You have to select activity 5.6 because it has got least slope, activity 1.4 it has got least slope. The cost will increase by how much? 25 plus 20, 45 days, right? So direct cost will increase by 45 days and the duration of the project will come down by 1 day. So indirect cost will decrease by 50 rupees. Again the total cost will decrease by 5 rupees. So let us go for this option. So what we are doing, we are reducing activity 5.6. So let me first draw network. So this is 1 already exhausted. We have to reduce 5.6. 5.6 is where? 5.6 is this, right? So this is now 6. Okay. And 1.4. 1.4 is where? 1.4 is this. Now this is 2. All other durations will remain same. 5, 2 and 10. All these activities are in this direction, right? So this is 6, right? Let us find out what is the total duration. So T is 0, T is 1, T is 6, T is, we will calculate it later on, right? So TE here is 3, T is 2, right? So from this side T is 12, from this side it is also 12, right? Now let us find out, anyway just calculate TL also, right? So TL is equal to 12, TL is equal to 6 here, TL is equal to 1, TL is equal to 0 and TL is equal to 2, and TL here is 12 minus 2 is 10, right. So again you have got two critical paths. Right. What is the total cost? Total cost would be, in fact, this 970 plus 45, right, plus 12 into 50, right. So this is 45, 1015, right, isn't it, and 600, this is 1615. Total duration is 12 and total cost is this. Now what to do? Shall we further decrease duration of this activity, this particular project? Because here we have got two critical paths, right, and the total duration is 12. You can do one more thing. Since you have got two critical paths here and there is still possibility of reducing its duration, so what you can do, you can further select any critical activity from this path and any critical activity from this path. Again you have to keep in mind the least slope concept, right. So here let me again write critical path. Okay, let me write here. So critical path is, you got 1, 2, 5 and 6, and you got second critical path is 1, 2, 4, right. No, it's 1, 4, 6. It's 1, 4 and 6, right. So let us look at slope 1, 2, no point, and this crash limit 5, 6, 2, 5. What is the slope? 34. For 5, 6, what is the slope? 25. Now its crash limit is 1. For 3, 4 it is still 3, right. For activity 2, 5 it is still 3, right, but this is now 1 for 5, 6, right. And for 1, 4 slope is 20, crash limit is 1. For 4, 6, what is slope? 30, crash limit is 1, right. So what decision will you take now? Select 5, 6 because it has got the least slope from here, and 1, 4 from here which has got least slope, right. Cost will decrease by, sorry, direct cost will increase by 45 rupees, indirect cost will that will decrease by 50 rupees. So let us draw that network, right. 1, 2, 3, this 4, so this is 1, 2, this is 3, 4, 5, 6. Right. We have to reduce duration of activity 5, 6. 5, 6 is this, right. Now this duration will become 5, and activity of 1, 4. 1, 4 is this. Now this will become 1. All others will remain same, right. So this is 1. In fact, now the other durations will remain same. So this is 5, this is 2, this is 10, right, and this is 3. Let us find out T and TL values. So TE is equal to 0 here, TL is equal to 1, TL is equal to 6, sorry, it's TE, right? TE is equal to 1, TE is equal to 6, TE here is 3, TE here is 1, and TE here is 11, isn't it? TL 6, TL 1, TL here is 1, right? TL here is 0. So again you have got two critical paths, this one and this one. Right? Now the total duration is 11 days, and if you look at the total cost at this point, what would be the total cost at 11 days? Total cost would be 1610. This would be the total cost, right? Now can you further reduce duration of this project? Is it possible? You have got you have already crashed to the maximum limit of these two, right? So this you have crash limit is achieved, and here also crash limit is achieved, right? So you cannot reduce this critical activity, this critical activity, and this critical activity. Now what is the option available? If you are asked to reduce duration of this project, what would you do? First thing is you have to reduce these two activities simultaneously, right? And that is the only solution available, or that is the only option available, right? So you have got these two options available. So 2.5 and 4.6. So for 2.5 this is the slope, and for 4.6 this is the slope, right? Isn't it? So you can reduce activity 2.5 and 4.6, right, by 1 day. But when you do that, your cost will increase by, your total direct cost will increase by 64 rupees. Your total cost, direct cost will increase by 64 rupees, and your indirect cost will decrease by 50 rupees. So this cost will increase by how much? 16 rupees, isn't it? No, 14 rupees. So that option is not advisable, but if you want, you can still do that. You can make one more final network just for your convenience. So total cost for this is 1610, right? For 11th day the total cost is 1610, right? Now just final network 2, 3, 4. This is 5, this is 6. So what we are doing, we are reducing 2.5. 2.5 is where? 2.5 is here. So this is 4 now, right? 2.5 is now 4, and 4.6. 4.6 is this. This is now 9, and all others will remain same, right? So this is exhausted. This is exhausted. This is 3. This is also exhausted. This is 2. Calculate TE value 0, T is equal to 1, T is equal to 5, T is equal to 10. Yeah, either from this side or this side. This is 1, right? So T is 3 here. So now simply you can write TL, this is 10, TL is 5, TL is 1, TL is 0 here, and TL is 1 here, right. So again this is your critical path. Okay. So what you have done here, you have reduced activity 4, 6 and 2, 5. So for 4, 6 also you have achieved its crash limit, right. Now what? Can you further reduce its duration? Is it possible? Just think for a minute. Can I further reduce duration of this project? Yes or no? No, it's not possible, because to reduce duration of this project I will have to reduce activities along, I will have to reduce critical activities along these two critical paths, and I have got only this critical activity available for reduction, but there is no critical activity available on this path, so I cannot further reduce its duration. So this is the last the minimum duration which is possible in this project, right. But what about cost? Cost has gone up in this case. So what is optimum solution to this question? What is optimum solution to this question? You need to draw, you can in fact prepare a table over here. So you can prepare a table wherein you can write down all the costs, and so when your duration is 16 days, direct cost is something, indirect cost is something, and you have got total cost, right. So 16 days this was the direct cost and indirect cost was 800, right. So total cost 1740. When duration was 15 days, 14 days, 13 days, 12 days, 11 days, 10 days. So direct cost was 950, then it was 960, then 970, then 1015, 1060 and 1124. Indirect cost of course 750, 700, 650, 600, 550 and 500, right. This is 550. Total cost is this is 1700, this is 1660, right. Then 1620, then 1615, this is 1610, and this is 1624. So if you look at this total cost curve, this total cost figure here, this is the lowest cost and the duration of this project is 11. So you should not reduce this project beyond 11 days. So if you want, what is happening here, let me draw a total cost. So this is the total duration, initially 16 days, now it is 11 days, right. So the total cost is now it has gone down like this, right. But if you further reduce it, it will go up, right. So this is your 11th day where the total cost is minimum. So let me summarize what we have done in this session. We have solved a question for finding optimum schedule of a project. So what we have done here, first of all we calculated slope for all the activities, then we found critical path, and for reduction in duration of the total project we selected those critical activities along critical path for which slope was least, right, and we then reduced its duration by 1 day. In all these networks, we have reduced the duration of critical activity every time by 1 day, though this is quite an inefficient method, but quite a simple method. We will look at some efficient methods of reducing duration of the project in coming sessions. So, for the time being, let me stop here. Thank you very much.